Welcome to our journey through the solar system, a valuable region over 4 billion years old, encompassing our sun, known planets, and numerous small, rocky, and icy bodies like asteroids and comets. The solar system is divided into several regions. The inner region consists of the terrestrial planets: Mercury, Venus, Mars, and of course Earth. These 4 planets are rocky and metallic, relatively small in size. During their formation, the heat of the sun expelled gases from this region, concentrating dense elements. Beyond Mars lies an asteroid belt, comprising millions of rock pieces, remnants of planet formation. Beyond this belt, we enter the realm of the giant planets: Jupiter, Saturn, Uranus, and Neptune. In this outer region of the solar system, low temperatures during formation allowed for the existence of volatile elements, making these planets larger than terrestrial ones, and composed of lighter elements like hydrogen and helium. The solar system's formation began with the collapse of a nebula following a supernova explosion. The primitive nebula flattened as it spun, its central part warming up to form a protostar, while dust rich in carbon, ice, metal, and minerals clumped together, a process known as accretion. These clumps eventually formed protoplanets, and after a few million years, the planets we know today. Earth, the third planet from the Sun, is unique in the solar system for having liquid water on its surface. About 70% of Earth's surface is covered with oceans, and its atmosphere is primarily composed of nitrogen and oxygen, conditions that have allowed for the development and evolution of complex life forms. Earth has always been subject to intense volcanic activity and has a circumference of about 133,000 kilometers. It is the only terrestrial planet with a 2-part core and 4 distinct layers. The outermost layer, Earth's crust, is 5 to 80 kilometers thick, mainly formed from volcanic rocks. Below the crust lies the mantle, hot yet solid, extending down to about 3,000 kilometers, and composed of minerals like oxygen, silicon, iron, and magnesium. Earth's core is split into 2 parts. The outer core, composed of metallic elements, generates the magnetic field through flowing electric currents, and the solid inner core, made of iron and nickel, subjected to tremendous pressures and temperatures reaching 6,000 degrees Celsius. Earth's atmosphere contains very little carbon dioxide, primarily dissolved in the oceans, and is dominated by nitrogen, followed by oxygen, argon, a few other gases, and water vapor. The transparent gases in our atmosphere become visible when water vapor condenses into clouds, which can cover up to 60% of Earth's surface. Saturn's moon Titan has an atmosphere most similar to Earth's in the solar system, while Mars has an atmosphere 100 times less dense, and Venus's is 100 times more dense. Ozone, a molecule containing 3 oxygen atoms, in the atmosphere, absorbs harmful ultraviolet rays from the sun, enabling life to thrive on Earth's surface. Earth's geology and complex climate distinguish it from other planets. Another unique feature is its crust, divided into tectonic plates that move in relation to each other. Other terrestrial planets are believed to have a single shell. The division of Earth's crust into tectonic plates leads to terrestrial movements. From space, Earth appears as a blue planet, mainly due to its surface being 2/3 covered by oceans and erosion having erased craters from asteroid and comet impacts. Earth's companion, the Moon, is one of the largest 5 moons in the solar system, and the only one referred to as Moon. The Moon lacks an atmosphere and life. Its surface, shaped by meteor impacts and ancient volcanic eruptions, displays dark and light areas offering starkly contrasting terrains. The darker regions, called seas, are vast plains formed by volcanic lava. Despite its weak gravitational field and distance from Earth, the Moon exerts a significant gravitational pull, influencing tides on Earth. During full or new moons, when the Moon, Earth, and Sun align, gravitational forces cause high tides, and the opposite occurs during quarter moons. Finally, the Sun, a vast ball of hydrogen and helium, constitutes 99.9% of the solar system's total mass. Though it appears enormous to us, with a diameter of about 1.4 million kilometers, it is a medium-sized star. The Sun is halfway through its life cycle, having already exhausted 35–45% of its hydrogen reserves. In about 6 billion years, it will expand, becoming a brighter but cooler subgiant star, eventually growing into a red giant before shedding its outer layers, leaving a white dwarf core. The Sun's core is where nuclear reactions occur, releasing energy that makes life possible on Earth. Our atmosphere acts as a shield, protecting us from harmful radiation. Join us as we explore the wonders of our solar system, a vast expanse ruled by the Sun, without which Earth and humanity would cease to exist. The sun's energy permeates our planet, allowing heat to enter while preventing it from escaping, simultaneously shielding us from dangerous solar radiation. This effect is known as the greenhouse effect. The atmosphere comfortably warms us during the day and night. Humanity is entirely dependent on the sun throughout its life cycle. The sun heats the land, oceans, and air. When water evaporates, clouds form. As the water vapor in these clouds cools, it turns into water droplets, eventually falling as rain. Humans, animals, and plants rely on this water. Plants use sunlight for photosynthesis, transforming carbon dioxide and water into carbohydrates they need to grow, while releasing oxygen needed for breathing. Mercury, the planet closest to the sun, resembles an iron ball surrounded by a thin rocky mantle. Like the moon, its surface is covered with impact craters. The Caloris Basin is one of the most prominent, large enough to encompass all of France. Mercury features cliffs reaching up to 3 kilometers high, formed by compression faults. Lacking an atmosphere or liquid water, Mercury's only erosion comes from meteor, asteroid, and comet impacts. It has no moon. Its proximity to the sun creates average surface temperatures around 430 degrees Celsius. Mercury experiences extreme temperature contrasts. Its night side can plunge to around -200 degrees Celsius. Smaller than Earth but incredibly dense, Mercury must have a substantial iron core. Venus, Earth's closest neighbor, is roughly the same size as Earth, but vastly different. It has a thick carbon dioxide atmosphere and sulfuric acid clouds covering its surface. The atmospheric pressure on Venus is like being 900 meters underwater on Earth. Venus's average surface temperature is hotter, reaching up to 490 degrees Celsius. Venus's surface is covered with volcanic structures like pancake domes, formed by rich gas-laden lava that spreads like pancake batter before solidifying and cracking. The highest volcano on Venus, Mont Mons, features lava flows hundreds of kilometers long. Mars, the fourth planet from the Sun, has a diameter just over 6,700 kilometers, about half the size of Earth. Its thin atmosphere, mostly carbon dioxide, leads to unstable climates and the formation of glaciers. Mars is home to numerous extinct volcanoes, including Olympus Mons, one of the highest known surface features in the solar system, reaching over 21,000 meters. Mars' early geological history was marked by meteor bombardment and volcanism. Old craters eroded by water have led to river formations. Mars likely had a hydrodynamic cycle with oceans regulating a temperate and stable climate. However, its low mass couldn't retain atmospheric gases, and the water cycle dispersed. The water may have evaporated and been absorbed by porous rocks. Mars's lower density compared to Earth is due to its smaller mass and less compressed layers. Its surface is covered with a thin layer of iron oxide dust, giving it the name Red Planet. The southern hemisphere is mostly high plateaus and impact craters, while the north has basins and large volcanoes. Mars has 2 moons, Phobos and Deimos, likely captured asteroids, irregular and crater-filled. Both are quite small, with diameters of 27 kilometers for Phobos and 15 kilometers for Deimos. The asteroid belt, a cluster of asteroids, orbits between Mars and Jupiter. Their irregular shapes and sizes range from small pebbles to mini-planets. The largest, Ceres, with a diameter of about 950 kilometers, is classified as a dwarf planet. Asteroids consist of minerals, metals, or carbon, and are filled with impact craters. Jupiter's gravitational pull prevents these rocky bodies from coalescing into a planet. Most asteroids in the solar system are found in the main belt, with thicknesses varying between 100 to 300 million kilometers. They are categorized into 3 families based on chemical composition and morphological features: C-type, carbon-rich; S-type, silicate-rich; and M-type, metallic. About 75% of asteroids are C-type, found in the belt's furthest regions, and are the least reflective. Could these drifting rocks threaten Earth? Some asteroid fragments might head towards Earth, causing impacts. These are known as meteorites. When a meteorite enters Earth's atmosphere at high speed, friction generates intense heat, causing it to burn and create a streak of light in the sky. If it doesn't burn up completely, the remaining piece can strike Earth, known as a meteorite impact. A significant asteroid collision can leave noticeable marks on Earth's surface and have dramatic consequences for life. Jupiter is the largest planet in our solar system and could encompass all other planets within it. Its composition is almost entirely gaseous, primarily made up of hydrogen and helium. Jupiter more closely resembles a star than a true planet. After Venus, Jupiter is the brightest planet. It has a compact core made of compressed hydrogen and helium, as well as rock and ice. This core accounts for about 5% of its total mass and is enveloped by volatile elements. Jupiter does not have a solid surface but a dynamic atmosphere. From Earth, we can see its varying dark and light bands, a pattern caused by its rapid rotation, which stretches atmospheric disturbances into a series of parallel lines. At the center of these bands are cyclones and anticyclones, the most famous being the Great Red Spot, owing its bright color to phosphorus-containing molecules. This anticyclone is larger than Earth itself. The Great Red Spot has been shrinking, from 40,000 kilometers in 1930 to 16,000 kilometers in 2014, and may disappear within 70 years. Jupiter's ring system remains dark, visible only in the planet's shadow. Jupiter is notable not just for its size, but also for having the most moons, with 95 known to date. Saturn is the second largest planet in the solar system, but it's famous for its rings, visible from Earth with a telescope. Saturn's rings are a world of their own, composed of numerous ice particles acting like independent satellites, some as large as a house. These are covered in highly reflective ice, making Saturn's rings brighter than those of other planets, reflecting up to 60% of sunlight. They are incredibly thin, with diameters of 280,000 kilometers but averaging only a few meters in thickness. Saturn also has a solid core of rock and ice, with an atmosphere mostly of hydrogen and helium. The deep, cloud-embedded atmosphere gives the planet a vibrant hue. One distinctive feature of Saturn is its flattened poles, caused by its extremely rapid rotation, completing a full turn in less than 10 hours and 30 minutes. Saturn's mass and gravitational field have captured numerous asteroids, now its moons. Today, Saturn has 83 known moons, with Titan being the second largest moon in the solar system, having a diameter over 5,000 kilometers. Titan is surrounded by a thick nitrogen layer and, being far from the Sun, has a very low surface temperature. As we move further from the Sun, we encounter Uranus, a blue-green planet, and the third largest in the solar system, 4 times the diameter of Earth. Its distinct color is due to the presence of methane, absorbing red radiation and only allowing blue to filter through. Unlike the gas giants Jupiter and Saturn, Uranus resembles an ice giant, denser with inner layers containing heavier elements like ice, in addition to hydrogen. Uranus completes an orbit around the Sun in just over 84 years, resulting in peculiar seasons. This is partly due to its rotation axis lying nearly in the plane of its orbit, leading to long periods of sunlight followed by prolonged darkness. During the winter solstice, one hemisphere can be engulfed in darkness for 21 years. Uranus has rings, currently 13 known, with low light reflectivity, making them hard to see. These rings consist of centimeter-sized dust particles, possibly formed from the disintegration of a small moon after a meteorite collision. Uranus has 27 known moons, with 5 being large and the others only a few tens of kilometers in diameter. The largest, Titania, has a diameter of 1580 kilometers. However, the most peculiar of Uranus's 5 large moons is Miranda, with a complex surface and extraordinary geological formations, as if it had been broken apart and reassembled like a giant puzzle. It might have shattered in a collision and later reformed from the pieces orbiting Uranus. Neptune is a gaseous planet and, unlike Jupiter and Saturn, is denser relative to its size. Neptune's atmosphere is characterized by winds exceeding 2,000 kilometers per hour and long-lasting large cyclonic storms. Its most visible dark spot is as large as Earth. The last planet in the solar system, Neptune shines with a stunning blue hue due to methane in its atmosphere, absorbing red radiation and allowing only blue to pass through. In addition to methane, its atmosphere is composed of hydrogen and helium. Neptune has a significant internal heat source, emitting nearly 3 times the energy it receives from the Sun. Neptune is surrounded by rings composed of dark, carbon-rich, dust-covered ice, difficult to detect. Due to its distance from the Sun, the exact number of Neptune's moons is unknown. Triton, the largest known moon of Neptune, features canyons, craters, hills, and very long fissures, creating a surprising landscape. It also has peculiar volcanoes, speculated to eject underground gas and dark carbon compounds. Pluto was once considered the 9th planet of the solar system, but was reclassified as a dwarf planet in 2006. Dwarf planets are approximately spherical bodies orbiting a star, usually found near other large objects like asteroids, comets, or other dwarf planets. As their name suggests, these planets are small. Therefore, they lack the gravitational forces necessary to clear their orbits of other objects. Pluto, with a diameter of 2,300 kilometers, is smaller than our Moon, but is the largest and second most massive dwarf planet. Its core, primarily rocky, occupies most of its volume. Pluto's surface is likely covered with a thick layer of ice, possibly mixed with traces of methane, nitrogen, and carbon monoxide, and features plains and mountains. It takes nearly 250 years for Pluto to orbit the Sun. Beyond Pluto lies a vast region filled with comets. The outer solar system, including the Kuiper Belt and the Oort cloud. Comets become visible with a luminous tail when they approach the Sun. However, there are billions of invisible comets in the solar system. Comets are divided into two families: long-period comets, which orbit the Sun at a great distance, and short-period comets. Long-period comets have orbits inclined to the planetary plane, suggesting they belong to a wide and spherical cloud that envelops the solar system like a cocoon. The Kuiper Belt is located at about 30 astronomical units and extends to hundreds of astronomical units, hosting hundreds of icy objects, some as large asteroids. This belt is 1,000 times smaller than the Oort cloud, which spans several tens of billions of kilometers and serves as a reservoir for long-period comets. The distances in the Oort cloud range between 30,000 and 100,000 astronomical units. This spherical cloud is hypothetical, as it has never been directly observed and lies far beyond the reach of our probes. Our knowledge of its existence comes from analyzing the orbits of several comets. In 1932, an early astronomer proposed that comets orbiting for long periods originated from a large cloud beyond the solar system's boundaries. About 20 years later, another astronomer suggested that meteorites couldn't have formed in their current orbits due to astronomical events. When a comet passes near the Sun, it loses part of its mass, turning into gas and dust. In a few tens of thousands of years, a comet could completely disintegrate. In fact, there is a vast reservoir of comets hibernating around the Sun. As the Sun moves through the Milky Way, it encounters other stars and is subjected to tidal forces. Comets can then be dislodged from the Oort cloud and directed towards the inner parts of the solar system. Comets consist of a nucleus surrounded by a bright gaseous envelope. A comet's nucleus can vary in color from black to red and gray, commonly composed of silicate and molecules of carbon, oxygen, nitrogen, and hydrogen. Like many other small celestial bodies, comets are invisible when far from the Sun. As a comet approaches the inner regions of the solar system, the heat causes some of its material to sublimate, mixing with other gases to form a tail and coma. During a short-period comet's passage, its material depletes, turning it into another small celestial body. Sometimes during its orbit around the Sun, Earth passes through the dust or gas left behind by a comet, creating stunning meteor showers in our atmosphere. When a comet's coma forms, carbon dioxide and carbon monoxide vaporize first, followed by ice. The released gas disperses into space, making way for new material. Sublimation occurs only on the side of the comet facing the Sun. Material emitted by the nucleus can spread across hundreds of thousands of kilometers in space. When a comet brightens and becomes visible, we can see its tail formed by gases from its coma. Most comets have at least two tails, one of ionized gas and the other of dust. The latter is not always visible. The gas tail has a bluish color due to the presence of carbon monoxide and can extend for several 100 million kilometers. They are always straight and consist of nodes and dense clumps that can suddenly break away from the comet's tail, making it one of the most spectacular events in the solar system. From our perspective on Earth, the solar system seems infinitely small, yet the universe is far from small. Our solar system is located in a galaxy called the Milky Way, a massive disk of moving stars with a diameter of almost 1,000 billion kilometers, potentially containing 130 million solar systems. Yet the Milky Way is just one among many galaxies. Galaxies are vast clusters of stars stretching across hundreds of thousands of light years. They come in a variety of sizes and shapes and are divided into two main families: elliptical and spiral galaxies. Spiral galaxies are further subdivided into simple spirals, barred spirals, and lenticular galaxies. Elliptical galaxies are the most massive, while spiral and lenticular galaxies can reach similar diameters to large ellipticals, but are flattened, making up 60% and 30% of galaxies, respectively. Barred spiral galaxies feature a thick bar of stars extending from the center to a spiral arm, and normal spiral galaxies have arms extending directly from the galaxy's core. Spiral galaxies are flattened disks with a central bulge of old red stars and a surrounding disk containing gas and dust clouds that give rise to new stars. As spiral galaxies rotate, density waves compress gas and dust, leading to the formation of bright blue stars that illuminate their arms. A spherical halo of old red stars and globular clusters surrounds spiral galaxies. Elliptical galaxies take on a slightly flattened oval shape with 3 axes of different lengths. Lenticular galaxies are lens-shaped, resembling both spiral and elliptical galaxies. They have a central bulge like spiral galaxies, but lack a spiral structure and only contain old red stars. There are 2 theories on galaxy formation. The first suggests galaxies form from massive gas clouds collapsing inward due to gravity. The second posits that galaxies assembled from smaller objects. Both processes might have been at work when galaxies formed 10 billion years ago. The Milky Way formed just 1 or 2 billion years after the Big Bang. The universe was then a vast expanse of hydrogen and helium. Some regions, denser than others, attracted matter through gravitational forces. These regions individualized into massive clouds, the precursors to future galaxies. Collisions during this time stirred gas, leading to the collapse of stars and star clusters. It appears that earlier in the universe, there were more spiral galaxies than today. The change in the universe's appearance is due to repeated collisions between galaxies. Spiral galaxies merging formed elliptical galaxies, explaining their large size and why they contain so much gas and many red stars. The Milky Way appears as a milky, whitish band crossing the sky, visible only in part and forming a ring when viewed from Earth. In reality, we see only one side of a galactic disk, composed of an endless array of stars beyond human visual perception. The Milky Way hosts numerous stars, planets, and clouds. A star is a ball of ionized gas primarily made of hydrogen and helium, the most abundant elements in the universe. Stars tend to collapse under their weight, a process known as gravitational contraction. Inside a star, nuclear reactions exert pressure outward, balancing these 2 forces and giving stars their size. The star's core is subjected to high temperature and pressure, where hydrogen nuclei collide to form helium nuclei. These reactions allow a star to shine for billions of years. The surface temperature determines a star's color. Our sun is a medium-sized yellow star. Stars are born in molecular clouds, vast gas areas with regions denser than others, attracting surrounding gas by gravity. A protostar forms and continues to contract until nuclear reactions begin, and a star is born. The north and south celestial poles are extensions of Earth's axis into space, marking the only motionless points in the sky. The North Star, Polaris, almost directly indicates the North Pole. Although not the brightest, it is crucial for navigation, allowing direction finding without a compass or GPS. The Milky Way contains billions of stars, but only about 3,000 are visible to the naked eye. The nearest star system to us is Alpha Centauri, a complex system of 3 stars. The 2 largest stars, resembling our Sun in size and color, form a binary star 4.37 light-years from our solar system, and are accompanied by Proxima Centauri, a small brown dwarf about 1.5 times the size of Jupiter. Proxima Centauri is slightly closer to us than the main components of Alpha Centauri, at a distance of 4.24 light-years. From Earth, Alpha Centauri shines impressively, being the 3rd brightest star in the sky. The 2 main components of Alpha Centauri form a magnificent binary star when viewed. The Milky Way has various star types, including binary, multiple, and variable stars. Nearly half of the stars in our galaxy are binaries. Binary and multiple stars are gravitationally bound and orbit a common center of mass. Binary stars form in the same collapsing cloud of matter, dividing into 2 pockets. Some clouds split into multiple parts, forming up to 6 stars. Variable stars change their light output. Periodic vibrations on a star's surface can also alter its brightness. The light emitted is a function of the star's surface area. Stars at the end of their lives expand and contract. They may experience unpredictable changes in brightness due to gas eruptions or other cataclysmic events. Algol is a striking eclipsing binary star, where 2 closely orbiting stars exchange matter and deform each other. The larger of the 2 loses a mass equivalent to the Sun every 50,000 years. Algol is located in the constellation of Perseus. In the grand scheme of the cosmos, humanity occupies a relatively insignificant place. Our planet Earth, a small rocky world, orbits the Sun, a medium-sized star, nestled in a relatively calm region of our galaxy. Despite our modest position, human ingenuity and technology have allowed us to explore and observe a vast portion of the observable universe, yet our understanding remains limited. We know the universe is expanding, and the visible matter like stars, galaxies, and planets represent only a small fraction of the total matter in the universe. Despite our humble place in this immense universe, we have developed the ability to think, reason, and comprehend the physical laws that govern our surroundings. We have created technology that enables us to investigate and delve deeper into the mysteries of the universe we inhabit. Though our position in the cosmic scale might seem inconsequential, we possess a wealth of understanding, appreciating the beauty and complexity of the universe around us. With each passing day, we push the boundaries of our knowledge, continually striving to discover more about this vast, enigmatic cosmos. In conclusion, while we may be just a speck in the grand canvas of the universe, our quest for knowledge and understanding of the cosmos remains unbounded. Our curiosity drives us forward, constantly expanding our horizon as we seek to unravel the secrets of this magnificent and intricate universe that we are a part of. The journey of exploration and discovery is endless, and each new finding is a testament to human resilience and the enduring quest for understanding our place in the universe.